Or number 3, talking about differentiability. First step, step 1, find out where it's continuous. It's continuous everywhere, so don't have to worry about that. Because if it's not continuous, it's not differentiable, but it is continuous everywhere. Step 2, derive that thing. H prime of x is equal to, let's do the 3/5 power. So 3/5 x to the negative 2/5, which is the same thing as 3/5 x to the 2/5. Now x equals 0 is a problem. Okay, so we need to investigate that. We know it's not differentiable there. However, the function is continuous. So there's only two possibilities. If a function is continuous and not differentiable, then it's either a corner or a cusp, maybe some people call it a cusp, or a vertical tangent. Okay, so those are our possibilities right now. A corner or a cusp, which is almost the same thing, or a vertical tangent. And remember, if it's a vertical tangent, that just means the function is vertical for one point. And since the vertical tangent would have a slope somewhere like infinity, that's not a number, so it's undefined there, and that's why you said it's not differentiable there. So these are our two possibilities. In order to find that out, we check out what's happening at 0 from the left and right of our derivative. So we check out the limit as x goes to 0 from below of h prime equals, and we check out the limit as x goes to 0 from above of h prime. Now, if these are different numbers, there's a corner there. If they were the same number, then it would be differentiable there as long as it was continuous. And if we get infinity for both of them, that means it's a vertical tangent. So as x goes to 0 from below on this thing, well, first thing you do is you plug in 0. And when you do that, you get 3/0, right? Now, when we talked about limits way back in, I don't know, a couple weeks ago, if you get a number over 0, that's a vertical asymptote. We know that. So there's a vertical asymptote on the derivative, not on the function, on the derivative. So we got to find out if it's going to positive infinity or negative infinity from the left-hand side. It's got to be one or the other if it's a vertical tangent. So all we need to do is check the sign of h prime as x goes to 0. That rhymes. Sign of h prime. Okay, awesome. Anyway, 0 from below. As x is going to 0 from below, that means it's negative numbers getting very tiny, but still negative. So we have very small negative numbers. We're going to square them, which turns them positive. Take the 5th root, which leaves them positive, times 5, also positive. So we have 3 divided by a very small positive number. And as that gets smaller and smaller, it's going to head to positive infinity. Checking out x going to 0 from the right of h prime, same thing's happening. X is becoming very small positive numbers, squared, and in the 5th root is going to leave them positive, and times 5, also still positive. So it's 3 divided by very small positive numbers, which is going to head towards positive infinity. So both sides of the derivative are going to positive infinity, which means our slope is going to positive infinity from both sides. And what that looks like is this. Okay? If you have a graph that has a vertical tangent, it looks like this. Okay? And at the point right here, you can see if you're riding on a roller coaster here like this, okay, then if you're holding a flashlight, let's say you're on the roller coaster and you're holding a flashlight and the flashlight is shining out like this. Okay? Well, everywhere you are on this curve, wherever the flashlight is shining, is the derivative. That's the slope of the tangent line. Okay? You're looking straight ahead. And once you get to this spot here, your flashlight's going to be shining straight up, which means there's a vertical tangent there. That's what's happening. And that's what we're going to say. So now we're going to write our answer out. We did all this work. This is write out our answer. We're going to say, and answer the question asked. So where's it differentiable? So h of x is differentiable on the reals except for x equals 0 and x equals 0. I'm writing cursive. There's a vertical tangent. There you go. That's why it's not differentiable there. That's all it's asking. Let's go to number 4. Now, really, you'd have all your work to show how you did this, and that's what, I mean, you should be showing your work. Otherwise, you could just guess, and that's not really fair. Anyway, for number 4, we got a square root. We want to know where it's differentiable. First, we got to find out where it's continuous. So the first thing, anytime you have a square root, you know this thing is not defined when what's inside the square root is negative. So we must find out where 2x squared minus 7x plus 6 is negative. That's what we want to do. We want to take out those points. And we said anytime you want to find out where something's negative or positive, the first thing you do is you find out where it's 0. So we got to factor this. And this is going to factor into 2x, x, what? Let me think here. 3 will be 6, minus 1, there we go. Minus 1, minus 3. So 2x squared minus 6x minus x is 7x. This doesn't work. That's terrible factoring. I'm laughing at myself, yes. 3 and 2, 2 and there we go, 3 and 2. There we go. So 2x squared minus 4x minus 3x minus 7x plus 6, okay. So this thing is 0 at 3 halves and 2. Now, we don't really care where it's 0, we care where it's negative. That's what we're trying to find. But we find out where it's 0 so that we can make our little number line. Put these numbers on there. So we know it's 0 here and here. Because in between and to the left, to the right, it can't be 0 because we would have found zeros there. So it's either got to be positive or negative. And we check it out. It's a parabola, so we know pretty much what the end behavior is going to look like. They're both going up to infinity, so they should be positive. If you don't believe it, plug in a huge negative number. Plug in 0 even. That's even easier. Plug in 0 down here and test it. Negative 3 times negative 2 is positive 6. Plug in a number between 3 halves and 2. Well, it's bigger than 3 halves, which means this one's going to be positive, but smaller than 2, meaning this one's going to be negative. Positive times a negative, negative. And plugging in a number bigger than 2, like 100 kajillion, positive times a positive is a positive. So, as long as 2x squared minus 7x plus 6 is positive, then we can take the square root of it. It's not positive between 3 halves and 2, meaning all the numbers between 3 halves and 2 are not in our domain. 3 halves and 2 themselves are in our domain because that would make this thing 0, and the square root of 0 is just 0. So the first thing we know now is the domain of our function is from negative infinity to 3 halves union with 2 to infinity. Okay, so automatically our function cannot be differentiable between 3 halves and 2. Oh, these should be brackets, I'm sorry. Let's get rid of these guys. Bracket, because we can include 3 halves and 2. We know it's not differentiable between 3 halves and 2 because the function's not defined there. So that's one area. Now we need to check out what's happening with the derivative. So we found out where it's not continuous. We did our work with that. Now we got to derive it. So k prime of x is 1/2 this thing to the negative 1/2. So that's going to be 2 square roots of 2x squared minus 7x plus 6 times the derivative of what's inside, which is 4x minus 7. Now, the only thing that's going to make this thing undefined, this is k prime of x, this thing undefined is either what's inside of here is negative, because then we take the square root of a negative number, that can't happen, or what's inside of here, this parabola, is 0. It cannot be 0, because if it's 0, then we take the square root of 0, which would be dividing by 0. We cannot do that. So, we've already taken out all the points between, we know where this thing's negative. We already took those points out. But we know this thing's 0 with 3 halves and 2. So we know that x cannot equal 3 halves or 2 because, and we're still going to write this out, but this is just me reasoning with you, because k prime of 3 halves and k prime of 2 are undefined. Okay? Because you plug it in, you get something over 0, which is undefined. So, that's what we got going on. K is not differentiable between 3 halves and 2 because the function is not defined there, and it's not differentiable at 3 halves or 2 because the derivative is not defined there. If you want to find out what's happening there, basically, this is the same thing that happened with the square root of x. Square roots always have a spot where they stop. Like, where's let's say 1, 2. This function looks like this. Something like that anyway. And what's going to happen at these points is going to be, well, there is no left-hand side at 2, which means you can't find the derivative there anywhere, because to find the derivative, you need a left and a right-hand side. So you can say that the function is not continuous at 2. It's called right-hand continuous, meaning that if you're approaching it from the right, then you can get to 2, no problem. But if you're approaching it from the left, you can't get to 2 because there's no points there. Same thing with 3 halves. It's left-hand continuous, but not right-hand continuous. You could also try and take the derivative here, the limit as x goes to 3 halves from the right, and you're going to find out that that is an infinite tangent, a vertical tangent. So basically what we're going to do is just say, not to get too complicated here, k of x is differentiable on negative infinity to 3 halves, not including, and from 2 to infinity, not inclusive. On 3 halves to 2, k of x is not defined. And at x equals 3 halves and x equals 2, t prime of x is not defined. And that's really fine. That's why it's not differentiable there. If you can go on to say there's a vertical tangent, but then you got to show the left limit and the right limit of the derivative and all that stuff. This should be a good enough answer. Describe what's happening at each point of non-differentiability. K prime is not defined. It's not a corner or anything easy like that. If it was a corner, we would just say that. But I guess just so we can say an answer. K prime of x is not defined since k of x is not continuous. That's probably our best bet, I guess. And it's not continuous there. It's right hand continuous at 3 halves, and it's left hand continuous at 3 halves, and right hand continuous at 2.